Hello, my name is Ross Nakatsuji, and I'm the product manager for Headwall's remote sensing systems. Today I'll speak about our solar induced fluorescence imaging sensor. Headwall has been a leading hyperspectral imaging sensor and systems provider. We're well known for our UAV based defense and industrial imaging systems. But along with those is an application focused sensor that we designed, build, and sell for manned aircraft and terrestrial use. We call it the Solar Induced Fluorescence Imaging Sensor. SIF can be assessed remotely using high-resolution spectral sensors in tandem with state-of-the-art algorithms to distinguish the emission from reflected and/or scattered ambient light. Plant reactions to stresses result in changes to the fluorescence emission. Many plant health, plant stress measurements report on latent effects where damage has already been done and beneficial factors have disappeared. Photosynthesis is a key process, and measurement of this in near real or real time is crucial to understanding mechanisms that are harming or helping vegetation. You can see that many research topics can benefit from SIF data. SIF is a comparatively weak signal that competes with the sheer amount of solar radiation coming from the sun. Sensors from handheld to tower and drone, manned aircraft, and satellite exist. Most are not necessarily meant for high spatial resolution imaging, but rather measurements at a point on a leaf or of a small area. Speaking of satellites, the first satellite specifically designed to measure SIF is currently due to launch in mid-2024, and many organizations have deployed or plan to deploy SIF instrumentation to complement what Flex will provide from orbit. So, with input from customers, Headwall designed and built a high spectral and spatial resolution sensor. You can see that the extraordinarily high spectral resolution of our SIF imaging sensor captures the very fine detail that is required for this application. Without this very high spectral resolution, the sensor simply would not work. In addition to airborne systems, environmental monitoring towers are candidates for these sensors, also pointing downward and capable of long-term imaging data capture of subjects like forest canopies.